So, in this unit, up until this lesson, if we wanted to use the power of trig ratios, we had to have a right triangle. Well, what if the triangle you're trying to work with or solve or whatever is not a right triangle? Well, we have two tools in our toolbox that let us deal with that. They are the laws of sines and cosines. So let's take a look at that. So the first thing is the law of sines. So both the law of sines and the law of cosines are useful in different situations depending on what you know. The law of sines says that the sine of the angles of a triangle to the opposite sides are proportional to the other ones. So we'd write it like this. All these proportional ratios are true for every single triangle in existence. So let's see how we might use that with a couple of examples. So we're going to find x and round to the nearest tenth. So this right here is not a right triangle, right? We know it's not a right triangle. We've got this 97 degrees. We could subtract from 180 to find this missing one. So we're going to use the law of sines. Now, to use the law of sines, we do say we're going to set up a proportion. So some fraction is going to be equal to some other fraction, right? And it's going to be the sine of something on the top, and then sine of an angle. So these two right here are paired, right? And then these two are paired, and they're paired because each set is opposites, right? So we can do the sine of 97 degrees to 16 equals the sine of 21 degrees to x. And now we can solve this like we'd solve any other proportion, right? Easy peasy at this point. So we're going to cross multiply and divide, right? So the sine of 97 degrees times x is x times the sine of 97 degrees, right? That's easy peasy. 97 degrees. And for the sake of working and keeping things exact, 16 times the sine of 21 degrees is 16, excuse me, times the sine of 21 degrees. 16 times the sine of 21 degrees. So now we need to get rid of this sine of 97 degrees. And so we're going to divide it off because it's multiplied on. Sine of 97 degrees. Sine of 97 degrees. Now, depending on context, you might just circle that and move on with your life. If the instructions said, write your answer as an exact solution, that's what we want to do. But since it says round to the nearest tenth, that clues us in and tells us that we want to get the decimal equivalent. So we're going to say x is approximately equal to, and we're going to pull out our calculator. Oops, not that. How about that one? All right, so 16 times the sine of 21 degrees. We know it's degrees because our calculator's in degree mode, right? And then divide by the sine of 97. So x is approximately equal to, we're rounding the nearest tenth, so 5.8. 5.8 units. Great. It's that simple. Easy peasy. Let's do another one. So again, we've got a triangle that is, we've got a triangle that we're trying to solve, and we don't have a 90-degree angle, so we're going to use the law of sines. Now you might be thinking, wait a minute. So x and 45 degrees are paired, but 10 doesn't have a known pair. So we got two unknowns. Well, this one we can find, right? This one's easy peasy. It's just 180 minus 45 plus 73, right? Because that's how we find the missing angle in a triangle where we know the three angles. So that is, let's see, 45 plus 73 equals that minus 180. This is going to give me the negative version of the same thing, right? Because I did it backwards in the calculator. So it's 62 degrees. 62 degrees right here. Now that we've got that, we can set up our law of sines. So we're going to set up a proportion. something is going to be equal to something else, and we're going to have signs on the top. And we're going to do the ones that match. So the sine of 45 degrees. Ooh, that's a special one. That one, you probably almost certainly don't have those memorized yet. I can tell you right now it's going to be a half, but we'll continue on to x equals the sine of 62 degrees to 10. Now we're going to cross multiply and divide, right? Psh, psh. So x times the sine of 62 is x times the sine of 62 degrees equals 10 times the sine of 45 is 10 times the sine of 45, which is actually 1/2. Or is it not? Is it this? No, it's not. It's not 1/2, but that's okay. Can divide by the sine of 62 on both sides. It is square root of 2 over 2, though. Sine of 62 degrees. Divide by the sine of 62 degrees. I thought I turned that off. If it keeps on doing things, then we'll silence it. I don't even know where it is because it's under my book over there. All right, so x equals, or is approximately equal to, we're going to put this in our calculator, 10 times the sine, I did it again. I did that on another video just a little while ago. Not 11, but 10 times the sine of 45 divided by the sine of 62 equals 8.0 units. Great. Easy peasy, lemon squeezy. So let's do the next one. So now the next thing is the law of cosines. Now, so the law of cosines is useful. It's a little bit more complicated, a little bit more ugly. It's not really any harder to use. I'll show you in a minute. It looks scarier, but it's actually not even that bad to memorize either. But it's useful when we don't have pairs. What if we know just one angle and then the sides on next to them? So that doesn't give us any pairs that we can circle. And if we only know one angle, we can't just subtract from 180 to get the missing angle like we did on the last one. So if we don't have enough information, then the law of cosines is the way to go. It is a little bit trickier. So when we can use the law of sines, that's the way to go. But if we can't, we can't. Now, so all of these follow a pattern. Basically, it says that the side length squared equals the sum of the other two side lengths squared. So in the A direction, A squared equals B squared plus C squared. So it's the ones on the side of it, right? The other two sides, minus 2 times, that's a mistake. There's a mistake in our writing. How about we put a B right there? There we go. Times those two sides, the same as these, multiplied times the cosine of its opposite angle, right? And that's true, and that goes for all of these, and it works that way for all of these. It's the square of the side plus equals the sum of the other two squares minus 2 times those two multiplied times the cosine of the opposite angle. Always. Let's do it with some numbers and kind of show you what we're doing. So we're trying to find x. So see, this is exactly what I'm talking about, where in this case, we only know one angle. And so if we only know one angle, we can't really use the law of sines very well. We need a couple different angles, or, you know, we can't quite make it work here. So let's set this up. So it's the side opposite. So this x is the one that's opposite of the other two that we have here. So x squared equals the sum of the two sides, so 11 squared plus 9 squared minus 2 times these two multiplied, so times 11 times 9 times the cosine of the opposite angle, so the cosine of 28 degrees. 28 degrees. So we're just going to punch all of this in our calculator. We're going to say x squared is approximately equal to all this mess. All right, so I'm going to kind of walk it down a few pieces at a time. 11 squared is 121. 9 squared is 81 minus 22 times 9. Probably could do that in our heads, but, you know, we'll make more mistakes that way. 198 minus 198 times the cosine of 28 degrees. Easy peasy. 121 minus 81. 1 minus 81. This is I've made several videos in a row, so that's why I'm punching some of these things in the calculator to cut down on mistakes. So x squared is approximately equal to 40 minus 198 times the cosine of 28. At this point, we can probably just shove all the rest of that in our calculator. That's going to be easy peasy. All right, so 40 minus, so I just hit minus because that 40 was my most recent answer, right? Minus 198 times the cosine of 28 equals something that shows me that I made a mistake. I'll be right back. Oh, I saw what the mistake was. I told you that I've made a bunch of videos at this point, prone to making mistakes. How about 121 plus 181 equals 202? 202. I'm going to double check because I'm making silly mistakes at this point. 121 plus 81. That's easy math, but, you know, better safe than sorry. So 202 minus, I knew that didn't quite look right. I thought that was probably going to end up negative, but it's like, I don't know. Anyway, trust your gut sometimes. Oops. Minus 198 times the cosine of 28 equals, that is a lot better looking, 27.18 x squared. Important, right? Don't forget that last step. X squared is approximately equal to 27.18. 0.18. We've got to get rid of that squared, and we do that, of course, by taking the square root of both sides. So I'm going to work smarter, not harder, and in my calculator, I'm going to do second square root of second, or shift, answer, enter, right? That way, and then we can find out that x is equal to 5.2. X is approximately equal to 5.2 units. Does that answer make sense? It absolutely does with those numbers. Easy peasy, lemon squeezy. Let's do another example, and then we'll do one that's a little bit trickier, but it's not going to be too bad. It's not going to be like the trickier one in the last video, but it is a little bit more involved. So we're going to look and see, do we have two pairs? We got this, and then, oh, no, we don't. We got to use law of cosines, which was to be expected because we had two laws of sines, two laws of cosines. Easy peasy. So let's do it. So it's got to be this pair right here, all right, because this is the angle we know. So 8 squared equals the sum of these squares, so 6 squared plus 3 squared minus 2 times their product, so 6 times 3. So that's it's not that bad to memorize. It looks scary, but it really isn't that bad. Times the cosine. Now you notice that this time we're looking for the angle. What does that mean? That means in a minute we're gonna have to use the inverse cosine to find our final answer. So let's start working these out. 8 times 8 is 64. Equals 36 plus 9 minus 12 times 3 is 36. Let me pause and look at this text message. All right, where were we? 2 times 6 is 12, times 3 is 36. That still looks right. I don't know. Maybe there's a mistake. It'll be fine. We'll all be okay. 36 plus 9 is 45. So we've got 64 equals 45 minus 36 times the cosine of x. All right, so we got to subtract 45 from both sides, right? Minus 45. Minus 45. Got to borrow. I'm making mistakes, so I'm going to chunk it in the calculator. just to be sure-ish. 19. Totally could have done it in our heads, but sometimes when you're tired, you just gotta do what you gotta do. 19 equals negative 36 times the cosine of x. We're going to divide both sides by negative 36. 36 divided by negative 36. 19 divided by negative 36 is going to be 19 divided by 36, right? 19 divided by 36 is 19 divided by 36. Yeah. So negative 19 over 36 equals the cosine of x. Now, we haven't found x yet, right? So I already gave you the clue earlier, but in order to find this, we always do the opposite. Well, what's the opposite of cosine? And when I say opposite, and often I will say in words, what do we really mean? We mean the inverse. So the inverse of cosine is inverse cosine, right? So we got to do the inverse on both sides. So we're going to turn this into the inverse cosine or arc cosine, right, of negative 19 over 36 equals x. And that we're just going to punch in our calculator. So shift cosine gives us the arc cosine or the inverse cosine, same thing, right? We talked about that last time, of negative 19 divided by 36 equals 125 nearest degree. So 125 degrees. All right, so x is approximately equal to 125 degrees. All right, we got one more example. This one's got a little bit more involved because we're going to solve the triangle. What does that mean? That means that we're going to have to find all of the missing bits. And so in this case, all of the missing bits are the angles, right? So we're looking for angles. So we just need to pick one and use law of cosines because we don't have any pairs, right? All of those things. All right, so pick one. Which one do you want to pick? There's sometimes moments where I wish I had students here. So let's do 15 because, hey, why not, right? So we got to use law of cosines for that. I'm going to kind of color code it. I'm going to mark this is A. That way we're kind of keeping things on track. So the 15 squared is what I'm trying to say. 15 squared equals the sum of the squares of the other two, right? So 13 squared plus 12 squared minus 2 times their product. So 13 times 12 times the cosine of the angle. So this is going to be a lot like that last one where we're looking for the angle. So we're going to end with finding the inverse. So 15 squared is 225, I think. I think that sounds right. Let's see. So 15, last time I said that on something, I was like way off somehow. So I don't know. 15 squared, 225. I remembered correctly. 225 equals 13 squared. I don't remember, 196? I don't know. 13 squared equals 169. That was like a dyslexic something moment. I don't know. Something going on. 12 squared, that one I do have memorized for sure. That is 144. 2 times 13 would be 26 times 12. So let's punch that in. 26 times 12 equals 312. So minus 312 times the cosine of A. 169 plus 144. I'm going to punch that in just because I'm going to make a mistake if I don't. I've said that on repeat. Maybe I'll just quit and you'll get words. 313 minus 312. Now since those numbers are real close, you'd be tempted to just subtract those and get 1. We can't. They're not like terms, right? This one doesn't have anything, and this one has a cosine of A attached to it. So they're not like terms, so we cannot just combine those, right? So we're going to subtract 313 on both sides, minus 313, minus 313. All right, so that minus is going to give me the opposite sign. Doing it this direction, 225 equals, it's actually negative 88, right? Because that 313 is bigger. So negative 88 equals Negative 312 times the cosine of A. Negative divided by negative is ultimately going to, I've switched colors, oh well, is going to give me a positive number. So I'm not going to worry about that in my calculator. I've talked about that before, that I often do the signs in my head. That way it kind of keeps me not making weird sign mistakes by just kind of writing down what's there without even thinking about it, right? So I know my answer is going to be positive, but I'm going to do that divided by, well, it's going to be, it actually is going to be positive. I've gone back to being correct-ish, right? So the cosine of A is approximately equal to 0.28. Cosine of, we switch colors again, I don't know what's happening, is approximately equal to 0.28, and I'm not worried about it being exact or how many decimal places, because I'm going to leave that number in my calculator, right? Good plan for you too. So the inverse cosine of 0.28 is approximately equal to A. So A is approximately equal to what? The inverse cosine of the previous number is 74. 74. Now you note that this now we have is 74 degrees. Is about 74 degrees, right? So now we can use the law of sines at this point, because now we have a pair of grouping things, right? So we've got these that go together. So we can pick either one of the other two to use the law of sines to do. So let's do these two with the law of sines. So let's do C next. We did nice in order. Let's do out of order. So we're going to set up a proportion with law of sines. So some fraction is going to be equal to some other fraction with signs on the top. Signs on the top. And so for our angles, we've got the A, which is 74. And I'm actually going to leave that in my calculator. Keep that, because that's not actually 74. It's approximately 74, right? That's just going to keep our exactness even more intact. Over 15, right, equals the sine of C. So we're going to use the inverse sine in a minute, right, to get that angle, just like we've been doing with all these other things, over 13, right? So we're going to cross multiply just like we've been doing. Easy peasy lemon squeezy. So 15 times the sine of C is 15 times the sine of C, right? 15 times the sine of C equals 13 times the sine of 74. Of 74 degrees, right? About 74. We're going to divide off that 15. So we're going to divide both sides by 15. Divide by 15, divide by 15. So the sine of C, we're going to use the inverse in a minute, equals 13 times the sine of 74 degrees over 15. So we're going to punch that in our calculator. Now, I'm going to kind of do it in different order than I normally would, because I want to leave this, I'm going to leave this less rounded. I was going to say non-rounded, but that's not quite true, because even the calculator's rounding it eventually, but the less rounded one in there. So I'm going to say the sine of the previous answer times 13 divided by 15 equals 0.83. So the inverse sine of that, the inverse sine of 0.83, 0.83 equals C, right? So the inverse sine, arc sine of the previous answer, that guy, equals 56.25. So 56 degrees. So C equals 56 degrees. That's easy peasy. Now that one, to find our final one, we can just add these up and subtract from 180. And then that is it. So 180 minus the sum of 74 plus 56. 74 plus 56 is 80 plus 50, so 130. I think that's right, but again, we're playing it safe. 74 plus 56 equals 130. That's what I said. I think we can go with 180 minus 130 equals 50. So B equals 50 degrees. There it is. That's it for that one. A little shorter than the last one. That example was a little crazy, but not too bad. We will see you in the next one. Like, comment, subscribe, all those things. Have a good day. Bye-bye.